Solve the following system of equations. If there is a single solution, answer it as an ordered pair x, y, z. If there are infinitely many solutions, parameterize your solutions in such a way that z is your free variable. Answer using reduced fractions if necessary. All right, so in order to solve a system like this, which is a large linear system, so it's a large system because there's 3 or more equations, and also there's 3 or more variables, which makes a large system. It's a linear system because all of those variables are just degree 1. So we could solve this using a couple of different methods. One method would be the substitution or elimination methods. This is a little bit complicated to do so and takes some time, so we'll avoid those. Another method is to use what's known as the Gauss-Jordan method. Now, the Gauss-Jordan method requires you to change your system into an augmented matrix to begin with. So in this case, that augmented matrix would look like the coefficient on the x variable in the first equation is 1. The coefficient on the y variable in the first equation is -2. And on the z, it's also -2. Then we put a bar in where the equals are, and then the constant value on the other side. So everything in this first column is multiplied by x. Everything in the second column is multiplied by z or by y. Everything in the third column by z, and after the bar is constants. So then we have -3x plus 9y minus 8z equals 3. And then -15x plus 45y minus 40z equals 12. Now, the next step here in this process using Gauss-Jordan is to go through a set of row or elementary row operations, which says that you can swap any 2 rows, you can multiply a row by a constant, a non-zero constant that is, and you can multiply a row by a constant and add it to any other row. And that will get you an answer, but it's also quite tedious because there's a lot of writing along the way. But the calculator is actually very efficient at coming up with these solutions for us. And the way that we do this is we take advantage of the matrix menu within the calculator. So you have to press second and the x to the -1 key to enter the matrix menu. Once you're there, to insert a new matrix, come over to the edit menu, and then matrix A is fine, even if you already have one in. Just set the size. In this case, 3 by 4 is fine. So we'll leave that alone. Won't change the size. I just need to change the coefficients of the system. So using the augmented matrix that I came up with, I'll enter those coefficients. And when you're finished, make sure you double check them, because if the calculator is doing all the solving for you, the only way that you can get a wrong answer is by entering the wrong set of coefficients. So be careful. All right, once they're in, you can hit second and quit to exit the matrix editor. And then if you hit second and x to the -1 again to go back into the matrix menu, you're now looking for a function under the math menu, which is RREF. Whoops, I accidentally went too far. Oops, there we go. I went too far down and hit the vars menu. All right, so RREF, that's the function we're looking for. It stands for row reduced echelon form, and it is in fact different than REF, okay? So RREF is what we want. Press enter, and now we need to insert the matrix that we just created. So hit second and go into the matrix menu again. But this time you just want the name of the matrix, which is matrix A, so just press enter, and that will pass a reference to the matrix coefficients that you entered. All right, when you run RREF, this is what we end up with. Here we have some fractions. If you want to, or decimals that is, but if you want to convert any decimals to fractions, the calculator has a great little item under the math menu. And it's the very first thing that pops up. It has a triangle and then frac. What it's saying is convert the output to a fraction. So if you press enter on that one, it'll say ants triangle frac. So what it means is convert the answer to fractions. And that's a little bit nicer format. So here we have the output 1, 0, negative 34 thirds, and 0, 0, 1, negative 14 thirds, 0, then 0, 0, 0, and 1. Okay, now, if you change this back to a system of equations, this is what it looks like. Remember, everything in the first column is multiplied by x. Second column is y variable stuff, then the z, and then constants. So we would have x minus 34 thirds z is equal to 0. Y minus 14 thirds z equals 0. And 0 equals 1, because there's no variables over here equal to 1. But 0 does not equal 1. That's a contradiction. And when you get a contradiction in a linear equation, what that means is there is no solution to the system.